Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on kinematics from March 2022, paper 2. In this question, we will discuss what is difference between distance and displacement and how to calculate total displacement of any object that is projected horizontally. And we will also discuss why the horizontal velocity of projectile does not change if there is no air resistance. For question number 2, it is given to us water leaves the end of a hose pipe at point P with a horizontal velocity of 6.6 meters per second. This is horizontal velocity. It is also given to us point P is at height h above the ground. So this is height h. The water hits the ground at point Q. At this point, water hits the ground. The horizontal distance from P to Q is 3.5 meters. So this is horizontal distance. It is also given to us air resistance in this case is negligible. And the only force that is acting on each droplet is its weight. Now for part A, we need to explain briefly why the horizontal component of the velocity of droplet remains constant as it moves from P to Q. Now in this case, simply we need to understand velocity remains constant if there is no net force acting on the object, or simply you can say acting on the body. And in this case, there is no force acting along horizontal, so it simply means that a horizontal velocity it will remains constant. So simply we can say along horizontal, simply we can write down here, along horizontal there is no net force acting. So simply we can say along horizontal F net is equal to 0. So it simply means that A is equal to 0. Horizontal acceleration is 0. So it means that delta V is equal to 0. So that's the reason the horizontal component of velocity remains constant, because there is no force on droplet of water in horizontal direction. So that's all what we need to write down. Imagine that if there was air resistance, for example, then you will see air particles like this. So imagine that if there was air resistance, then what will happen? So you can imagine these are air particles. Now when water will be falling, water will hit, let's say this is one big droplet of water. This one hit this air particle. When it will hit air particles, it will apply force on air particle in this direction, and air particle will apply force on this one in opposite direction. So you can see this resultant force on this droplet, it has two components. One component is upwards and one is to the left. So if there was air resistance, then this air particle will decelerate along horizontal and also it will decelerate along vertical. But in this case, there is no air resistance. So the horizontal component of velocity will not change, but vertical component of velocity will change because there is gravity that is acting in downward direction. But this question is only asking us about horizontal component. So as there is no force along horizontal component, so it simply means that horizontal component will remain constant. So simply you can say no force along horizontal, no net force, better to say no net force. So delta V is equal to 0. So let me show you how you can write down the answer. This is how you can write down the answer if you have mentioned this point, because force on droplet of water in horizontal is 0. So this is the main point. If you have written this one, you will get 1. For part B, we need to show that the time taken for a droplet of water to move from P to Q is 0.53 seconds. For this question, we have horizontal velocity. So horizontal velocity is given to us, and horizontal displacement is also given. So simply we can consider horizontal motion and we can find out value of time. So in this case, we are talking about horizontal motion. For horizontal motion, we can write down horizontal displacement. This will be equal to ux times time plus 1/2 ax t square. But in this case, ax is equal to 0 because there is no resultant force acting along horizontal. So ax is equal to 0. So simply we can write down, in this case, horizontal displacement is equal to ux times t times time, because ax is equal to 0. So it means this term is equal to 0. Now we need to find out value of t. So we can rearrange this. We can write down horizontal displacement divided by horizontal component of velocity. Horizontal displacement in in this case is 3.5 meters. Simply we need to divide this one by horizontal velocity. That is 6.6 meters per second. So our final answer in this case will be 0.53 seconds, and this is the answer. This question has only 1 mark. If you have got this right answer, you will get 1 mark. For part C, we need to calculate height. It simply means that we need to consider vertical motion now, because height is the vertical displacement. So we have to consider for this part vertical motion. For vertical motion, we need to understand the initial velocity of this object, means water, is only horizontal velocity. So it has no velocity along vertical. So we will say initial vertical velocity. We can simply say uy. This one is equal to 0, and the time taken from this point to the ground, from P to ground, or time taken from P to Q, it is the same. So we can simply say time taken is 0.53 seconds. You also need to understand time taken depends on height. Time taken does not depend on horizontal displacement. Let's try to understand this one with this equation. Time taken for horizontal motion, this is equal to Sx over Ux. If we increase the initial horizontal velocity, horizontal displacement will increase, but time will stay same if there is no air resistance. We are talking about ideal case, no air resistance. So we are talking about ideal case when no air resistance. If no air resistance, if you increase Ux, Sx will increase, but time taken will stay same if height is the same. So we are saying if height is the same, means we don't change the height, time taken will be the same if we change the horizontal component of velocity. Imagine that in this case we increase this velocity to 8.0 meters per second. So in this case the horizontal displacement will increase. So maybe ball will reach this point. So we can say this is Q prime. But time taken still will be the same because it is independent of horizontal component of velocity. Very important point. They can ask you this one next time in a different way. Now the next thing we need to understand, along vertical there is acceleration that is due to gravity, and the value of that one is 9.81 meters per second per second. We need to find out vertical displacement. It simply means we need to find height. In this case acceleration is constant, so simply we can use S is equal to ut plus 1/2 at square, and in this case we need to choose one direction. Now we will take downwards as positive. If we take downward positive, it means acceleration is positive and value of displacement also will be positive. U in this case is equal to 0, so simply we can say this is equal to 0 plus 1/2. A is equal to 9.81 and time is 0.53. So if you do this calculation, our final answer will be 1.4 meters. And this is height, means this is the vertical displacement. Our answer has 2 SF because in the given data, least number of SF we have 2. So this has 2 SF. So our final answer also have 2 SF. So this is our final answer. And this question has 2 marks. The first mark is C mark if we have used this equation. So this is the C mark. And the second mark is answer mark if we have done these calculations correctly. You will get the second. So 2 marks for this question. For final answer we can write down 1.4. Unit is given is meter. For the movement of a droplet of water from P to Q, state and explain. State and explain. Very important. You have to state, then you have to also explain whether the displacement of the droplet is less than, more than, or the same as the distance along its path. So the first thing we need to understand, what is displacement? Displacement is the shortest distance between any 2 points. In this case, displacement from P to Q, this is the displacement. So this straight line is the displacement from P to Q. And you see this curve, this one is the distance. So simply you can see from here, in this case, displacement is less. So we will state displacement is less than distance. So simply you can say this is the statement you have given. Displacement is less than distance. Why it is less than? Now you need to explain. So here you need to write down the explanation for that. You need to explain. Because displacement is a straight line distance, you can simply say because displacement is a straight line distance. Straight line distance from P to Q. So this is our explanation from P to Q. From P to Q. So this is how you can answer. Let me show you a proper answer for this question. For this question, simply you can say displacement is straight line distance from P to Q. So less than distance along the path. So this one is over distance. So let me highlight. Maybe some student, they will not be clear what exactly it means by distance. So this one is the distance. This blue line, this one is the distance. So this is distance. This one is distance and this one is displacement. So this one is displacement. So in this case, displacement is less than distance because displacement is a straight line. And this question has only 1 mark. If you have written less and then you have explained, you will get this mark. For the last part, we need to calculate the magnitude of the displacement of water droplet that moves from P to Q. Means we need to find out the displacement from P to Q. The total displacement, I will simply say. So this one is displacement. For this question, we have already calculated vertical displacement. So this is our vertical displacement. Then the value of this one is 1.4 meters. Now simply we need to find out value of total displacement. And this is just a right angle triangle. So simply we can say in this case, net displacement will be equal to 3.5 square plus 1.4 square and also the square of this. Or simply we can say this will be equal to 3.5 plus 1.4 and we can take the root of this. So the final value of displacement we can find out. So this is our displacement. So displacement in this case will be equal to 3.8 meters. And this question has 2 marks. If we have written the first one, you will get 1 mark and this is 3 mark. And the second mark is answer mark. If you have got the right answer, you will get the second mark as well.